Hey guys, this is lesson 1.7, the last lesson in this unit. And again, just to reiterate, the essential question is how can you tell if two quantities which appear to be different are the same? Today's lesson aim is going to be how do we divide polynomials which are not easily divisible. So the first example we're going to do is just kind of to recall how to do long division, something you probably haven't done for a really long time. So if you remember, we put the thing that we're dividing by on the outside, and we put the thing that we're dividing into underneath this little like radical symbol. And then we're going to see how many times does 4 go into 2. Well, it doesn't go into 2, but 4 goes into 25. So 4 goes into 25 6 times, because 4 times 6 is 24. So I'm going to multiply that back. I'm going to do 6 times 4, which is 24, and write it underneath here, and then I'm going to subtract. 25 minus 4 is 1. Bring the 6 down. How many times does 4 go into 16? It goes in 4 times. I'm going to write that up there. And I'm going to multiply that back. 4 times 4 is 16. Write it underneath, and I get 0. The number I get here is called my remainder. That's called my remainder. So I could say that 256 divided by 4 equals 64. I could say that 256 over 4 equals 64. I could also say that 256 is equal to 64 times 4. And I could also say that 64 and 4 are factors of 256. All right, let's do one more. So let's do the other one. 263 divided by 4. So again, the 4 goes on the outside, the 263 goes underneath. 4 goes into 26, again 6 times. 6 times 4 is 24. I'm going to subtract. 26 divided by 4 is 2. I'm going to bring down the 3. 4 goes into 23 how many times? 4 goes into 23 5 times. 5 times 4 is 20. And if I subtract, I have a remainder of 3. So again, this is called our remainder. So how do we write this? So 263 divided by 4 equals 65 and a little bit more. What we do is we take this remainder and we put it over the thing that we were dividing by. So it's 65 and 3/4. 263 divided by 4 is 65 and 3/4. All right, you're going to see that today. So what we're going to do is we're going to do long division, but with polynomials. Seems a little scary, but it's okay. We're going to do lots of examples. You'll get the hang of it. So first example, 2x squared plus x minus 10 divided by x minus 2. The reason that we need long division for polynomials is when a polynomial that I'm dividing, or polynomials that I'm dividing, don't go in evenly, like we saw here. This is why we need long division, when things don't go in evenly, so we can figure out what they are. So here's the thing I'm dividing by. So that's going to go on the outside. And then the quadratic's going to go underneath. And now I'm always going to start with the first term here, so the x in this case. How many times does x go into 2x squared? So you can think of it like this. Well, 2x. I'm going to put the 2x on top. So 2x times x gives me 2x squared. I'm going to put that below, just like we were doing for the other problem. But now I also need to multiply this 2x to this negative 2. 2x times negative 2 is negative 4x. I'm going to subtract these things like I did before, but I need to put this in parentheses because I'm subtracting all of this. So when I subtract this, what you should get is 0 here, and then x minus negative 4x. It's x minus negative 4x. X minus negative 4x. I'm going to do this on the side. X minus negative 4x. That becomes x plus 4x, which is 5x. So I'm going to write 5x down here. I'm going to bring down the next term, negative 10. Okay, now I'm going to ask myself, how many times does x go into 5x? Well, it goes in 5 times, so I'm going to put plus 5 up here. And then I'm going to multiply this positive 5 back to this whole expression. 5 times x is 5x. 5 times negative 2 is negative 10. I'm going to subtract 5x minus 5x is 0. Negative 10 minus negative 10. Negative 10 plus 10, which is 0. Okay, so what we just determined is that x minus 2 goes into 2x squared plus x minus 10 evenly. What you get when you divide them is 2x plus 5. There's no remainder because this is where the remainder would be. There's no remainder. So what this also means, like we just wrote for the last problem, what this also means is a few other things. It means this. It also means that 2x squared plus x minus 10 is equal to x minus 2 times 2x plus 5. And it also means that x minus 2 and 2x plus 5 are factors of this quadratic. Okay, these are all really important things, those 3 things that it means. All right, so let's go on. Let's do another example. Use long division. We want to divide x squared plus 3x plus 5 by x plus 1. Okay, so what I'm dividing by goes on outside, and this goes underneath. So, how many times does x go into x squared? It goes in x times. Because, if I think about it like this, there we go. Now I'm going to multiply this x back. X times x is x squared, x times 1 is positive 1x. I'm going to subtract. X squared minus x squared is 0. 3x minus 1x is 2x. I'm going to bring the 5 down. If you are getting lost, pause the video, rewind a little bit, and watch it again. Now again, how many times does x go into 2x? It goes in twice. You can think of it this way. Now I'm going to multiply this 2 back to the expression. 2 times x is 2x. 2 times 1 is 2. And I'm going to subtract. I need these parentheses. These parentheses are mucho importante. That's Spanish for very important. Okay, so 2x minus 2x is 0. 5 minus 2 is 3. Now I have a remainder. So how do I write this when I have a remainder? The last one was nice and easy. This divided by this equals this guy because there was no remainder. Now we have a remainder. So here's how we're going to write it if you remember from the first example that we did. X squared plus 3x plus 5 divided by x plus 1 equals x plus 2 plus the remainder, which is 3, over x plus 1. Only the remainder goes over x plus 1, not the other part. So the x plus 2 here, that's not over x plus 1. So technically this is what we get when we divide x squared plus 3x plus 5 by x plus 1. Okay? So a few things. What this tells us is that x plus 1 is not a factor of x squared plus 3x plus 5 because it doesn't go in evenly, right? Just like we saw in example 1. Here's example 1. Just like we saw here, 4 is not a factor of 263 because it doesn't go in evenly, right? If you made a factor tree for 263, you wouldn't put 4 because 4 times 65 and 3/4 is how you get to 263. You only put the whole numbers that can multiply to this. So 4 would not be a factor of 263. And similarly, x plus 1 is not a factor of x squared plus 3x plus 5 because it does not go in evenly. Okay, so now I'm going to give you a little of the math jargon here. This is the division algorithm. If f of x and d of x are polynomials such that d of x does not equal 0, I'm going to stop. F of x and d of x, what the heck is that? It's notation. It's just like a way of naming a polynomial. Like I'm going to call this polynomial red, and I'm going to call this one blue. I'm going to call this one f of x, I'm going to call this one d of x. So if I have two polynomials such that this one isn't 0, and the degree of this one is less than or equal to the degree of this one. So that's just saying this one is bigger, kind of. You can think of it like that. Then there exists unique polynomials, so there exists another polynomial, q of x and r of x, such that this is true. F of x equals d of x times q of x plus r of x. Okay, so let's analyze this a little bit. What this is saying is basically what we just did. We'll take it back to that example that we did in the first example. 4 divided by 263. Okay? So if 263, if 263 and 4 are polynomials such that 4, this one is not 0, which it's not, and the degree of this is less than or equal to this, well, there's no degrees necessarily here, but this number is smaller than that one, then there exists a unique polynomial, q of x and r of x, such that this is true. Okay, well, we found that 263 is equal to 4 times 65 plus 3/4. That's all it's saying. This and this are the things that multiply together to give you this, and this is if there's a remainder. Okay? So then the bottom part, where r of x equals 0, or the degree of r of x is less than the degree of d of x. If the remainder equals 0, then d of x is a factor. Okay, so that's like the other example we did, the first one. 256 and 4. So 256 divided by 4, what was it? I forgot. I go back. 64. Was 64, right? There was no remainder with that one. So what that means is that 4 is a factor of 256. So basically all this fancy stuff is saying that if there is no remainder, then the thing you divided by is a factor. Is a factor. Okay? So because there was no remainder here, it was just 64, that means that 4 is a factor of 256. But here, since there was a remainder, that means 4 is not a factor of 263. All right? Okay, we're going to talk about this more tomorrow. We have one more example that I would like to do. This example is important, and you'll see why. Is x squared plus 1 a factor of negative 4x cubed plus 3x to the 4th plus 5 plus 12x squared? Justify your answer. Okay, well, we just talked about this. If I want to determine if it is a factor, I have to see, is there a remainder? That's really kind of what I'm asking. If there is a remainder, then no, it's not a factor. If there is no remainder, then yes, it's a factor. First thing I want to do is I notice that the exponents are not in order here, and that just bugs me a little, so I'm going to rearrange. So I'm going to put the x to the 4th first, then the x cubed, then the 12x squared. There's no just term within a regular x to the first, so then the plus 5 goes after. Okay, so I rearranged this. Now I'm going to set up my division problem. I don't necessarily need this plus in front. I'm dividing by x squared plus 1. So you're going to see some kind of like funky thing happen, and you'll see. Okay, so I'm going to see how many times does x squared go into 3x to the 4th. You can always do it on the side if you need to. Okay, it goes in 3x squared times. So I write that up like 3x squared. Not necessarily lining that up with anything on the top. Now I'm going to multiply this back to the binomial outside. 3x squared times x squared is 3x to the 4th. 3x squared times 1 is 3x squared, right? Where do I put that 3x squared? Well, I want to put it underneath this because this is also an x squared. I can't combine it with the negative 4x cubed, so I'm going to put it under there. So then what goes kind of like in this hole here? You can just put a plus 0, just as like a placeholder. Now I'm going to subtract all of this. I need these parentheses so that I remember about the negative. Common mistake, one of the biggest common mistakes is this, dealing with this negative out here. Oftentimes people will just subtract these first two terms and then we'll end up adding these two terms because they forget about the negative outside. Okay, so let's start subtracting. 3x to the 4th minus 3x to the 4th is 0. Negative 4x cubed minus 0 is just negative 4x cubed. 12x squared minus 3x squared is 9x squared. And then we can bring down this plus 5. Okay? Now we're going to continue. How many times does x go into negative 4x cubed? How many times does x go into negative 4x cubed? So I'm going to divide on the side. Oh, sorry. How many times does x squared go into negative 4x cubed? Okay, well, it goes in negative 4x times. I'm just dividing. So I'm going to write that up there, negative 4x. Okay? So now I'm going to take that negative 4x and I'm going to multiply it back here. Negative 4x times x squared, negative 4x cubed. Negative 4x times 1 is negative 4x. I can't line this up with anything because there's no just x term here, right? So I'm just going to keep that in mind that I can't combine this with anything. Negative 4x cubed minus negative 4x cubed is 0. 9x squared has nothing to be combined with, so it's just 9x squared. Now I have to take care of this negative 4x. Technically, you can think that like there's a plus 0x plus 5 here. Okay, so 0x minus negative 4x would become, because of these double negatives, this would become positive 4x. And then I could bring the 5 down. This is a little confusing. This is why we're doing this example. That's why I wanted to do this. Okay, so let's keep going. So now I have to ask myself, how many times does x squared go into 9x squared? It goes in 9 times. 9 times x squared is 9x squared. 9 times 1 is plus 9. I'm going to make that line up with a 5. I'm going to put my parentheses around that, and I'm going to subtract. I'm going to just put a 0 here as a placeholder. 9x squared minus 9x squared is 0. 4x minus 0 is just 4x. 5 minus 9 is negative 4. Now, I know I'm done when I can't divide anymore. For example, x squared does not go into 4x, so I'm done. So that means I have this remainder. Okay, so the question asked, is x squared plus 1 a factor of negative 4x cubed plus 3x to the 4th plus 5 plus 12x squared? Justify your answer. All of our work is a justification. All this question is asking is there a remainder? Yes, there's a remainder. Our remainder is that x to the, where's our remainder? Here it is. Our remainder is 4x minus 4. So No, this is not a factor. No, x squared plus 1 is not a factor because there's a remainder. Okay? All right, guys. That's it for now. Remember to write your reflection at the end of your notes. Your reflection can be in the form of a summary. Your summary should be detailed though. It could be in the form of a clarifying question, or it could be in the form of creating an example and showing the work for it. All right, guys, I'll see you tomorrow.